Hello everyone. Today in our software engineering course, we will discuss about software maintenance, and inside software maintenance we will look into one aspect which is reverse engineering. The topics that we will cover is we will introduce software maintenance and look into the types of maintenance activities. We will take a look into the evolution, and there are some maintenance laws, and what are the difficulties of doing maintenance, how to do a good maintenance, what are the basic aspects of good maintenance, and then we will discuss about reverse engineering. So to introduce maintenance to all of you, maintenance is the last activity in the software process model. If you remember the process model which we started in our very beginning of this software course, after the construction or the implementation, which included the testing, we were the last one is to release the software and continue with the maintenance of the software. It is very important for the software to be maintained in a state which will be continuously providing the intended functionality and the performance to the end user. Once they have received the software, they will go on exercising it for their business function. So, as and when they do, the software has to be maintained in the good state so that it will continue to provide the service without any failure. Many people think that only bad software product needs maintenance. If we have not produced a good software, then there will be a lot of maintenance cost. But that is only a myth. The actual truth is that bad products are thrown away. They are not accepted by the customer. Customer only accepts good products. So there is no scope for the development team to produce a bad product and release it to the customer. So only good products are released, and because they are good products, they will be used for a long time. And anything when it is going to be used for a long time will require some maintenance. If it was a hardware or a physical item, there would be some wear and tear. But since it is a software, what will happen is it will require its functionality will change, its requirements will change, or some other environment will change. So we will see what are this maintenance we will be doing and why we will be doing the maintenance. But it is true that maintenance is a definite property of the software, and especially those software which are good products and likely to last for a very long time, many years, 10 to 15 years. It will be being used by the company who owns it, until and unless they are not able to use for some reason. Any modifications to the software product after it has been delivered to the customer is a maintenance activity. So whatever happens after it is released, because the development project is over, we call it as a maintenance activity. So the type of maintenance that we do are, it's not three, actually it should be four, because I have added one more. It's corrective, adaptive, and perfective. Normally people talk of these three. We are also talking of re-engineering because some people call it the fourth one. But as you we will see later, that re-engineering is a one type of perfective maintenance. So if you are asked what are the three major categories, you should say corrective, adaptive, and perfective. But if you are given the choice, then you can differentiate between perfective maintenance and a special type of perfective maintenance, which is re-engineering. So what is corrective maintenance? That is to correct the bugs. When I say bugs, that means defects observed while the system is in use. We have said that it is not possible to test and fix all the errors that is there in the system while doing the validation. So some remaining residual defects will remain, and those defects will be observed only when the customer is doing the work in after the release. So these bugs will be reported, and we will have to do the corrective maintenance. Sometimes there will be some performance problem. Then we have to do. Then they will report it that the product is not correct. Then we have to do corrective maintenance. Then there is adaptive maintenance. A software product may need modifications when there is a need to change the environment. So it was developed for a particular environment, some kind of platform was used, but later on it needs to be changed. Need the product to run on a new platform. Maybe the platform is not supported anymore, so you need to move it to a new platform. Or the operating system has got changed, and you have some products that interface. Now you have to write. You have to see whether all your software is actually adapting to the operating system, or some change has to be done. Similarly, suppose there is a new hardware or a software, and there is a need to interface with it. Then you have to change it. You have to change your your software product, so that the interfaces with the new hardware and software will be established. So that this kind of maintenance is called adaptive maintenance, because you are continuously adapting to a changed environment. Then the final one comes as the perfective maintenance. These are basically enhancements that are carried out. Enhancements means some extensions, some additional features to support new features required by users. That is what we said. New features will have to be added. Product will be enhanced. To change some functionality of the system due to some customer demand. Some customer has got some new requirements or a new way of working. So the software has to adapt to the new way of working. So that functionality will have to change, or the behavior will have to be changed. Maybe the screens will have to be changed. So that is called as a perfective maintenance, because we are not adapting to a platform. It is not a defect, but it is something the customer says, I will live with this software. I like this software, but I have got my method of working has changed. So I need new features. I need some changes to adapt to my own operations. So that is called as the perfective maintenance. Now, there can be one more type of perfective maintenance, which is called re-engineering, and it is carried out for making the software for future use. That means, suppose as a result of doing lot of there are two reasons. So we'll read it. It may result due to business process re-engineering. What is business process re-engineering? Business process is with the way process is carried out in the business. So suppose this business process itself re-engineered. That means the way they were doing the business, that has got changed. The process, the activities have got changed. The sequences have got changed. The way they conducted, the way they interacted with their different entities has got changed. Or maybe the forms have got changed, or some regulation has got changed. So they cannot carry on with the existing software. The existing software has got to be re-engineered or rewritten. And similarly, if the existing software, after having undergone corrective maintenance, adaptive maintenance, and preventive maintenance for many years, it becomes inefficient. Therefore, what they need to enhance its efficiency. They want to make it more user friendly. They want to enhance some of the features and performance. So they want a very extremely major change, which will totally overhaul the existing software. Its basis may get changed. So then we call it as a re-engineering. And so now many times it happens when the software is still useful, but it is not maintainable anymore, because it has undergone many enhancements. So many of its inherent processes have become weak or inefficient. So you have understood what is each of these different categories of maintenance. So now let's look at why what are the major causes of software maintenance? Why exactly these kind of things comes? So we'll see some examples. There can be several reasons which will lead to maintenance of the existing software. So, for example, when we developed by looking at the current requirement, but the software will live for 10 to 15 years. So it's a long time. So it is difficult to anticipate how long it will last and what are all the changes that it will, what are all the features that it will require in that time. So there could be privacy issues, there could be regulatory changes, there could be international legal issues, there could be something like a Y2K problem. So these are the things for which nobody thought of it. People who wrote programs in 1960s, 1970s, they never knew what will happen in 2000, how the program will get affected. So all their date computations became invalid when the Y2K came. So this kind of things, it is very difficult to anticipate, and you cannot say that I will need a requirement 15 years in future, so I will do it now. All the time we are looking at the current requirements, and we are looking into some kind of maintainability, flexibility characteristics of the software. So that is one reason why a major software maintenance may happen. Then the rate of hardware obsolescence is very high. And we know that software is sitting on the hardware. The computing environment is being given by the hardware. The methods, the algorithms are being given by the software. So software has to be moved to new computing environment, and maintenance necessary for software performing low level functions which may not be supported. So this existing software may be doing some low level functions, might be interacting with the hardware, previous hardware, but now it is not supported anymore in the new hardware. So you need to replace it with whatever is available with this new hardware interface, and release the new software again, the corrected software again. So that is another kind of major type of cause for which you have to do software maintenance. Then user wants software to run on new platforms, because new platforms will give some enhanced features and higher performance. So if you want to, for example, if you want to replace, you had previously UI modules which were character mode, or even if they were GUI, they were client server type. But now you want to move it to enterprise Java, or you want to make it web enabled, so that over internet it can be used. So those are either from standalone you moving to enterprise, like that. So if you want to have some good features, so then what you have to do, the technology, underlying technology will change on which it was made, or in other words, you want to turn it on a new platform, new technology. So then you will have to move it, so that an adaptive maintenance has to be conducted on the existing software. And whenever there is a change, whenever a product works with other software and that other software will undergo a change, then because this interface is there, so you have to need the change in the existing software to cope up with the new interface. For example, a software product may need maintenance when the operating system changes. Also, when you have web enabled systems, applications, you know that your web screens, web apps, they will depend on the kind of browser you are using. If the browser undergoes a change, then you may have to change your application. You have to make it portable to different types of browsers. So that is how it happens. Suppose it is very closely interacting with another software which is undergoing a change, then you will have to change, adapt your product. We will look into the more on the software maintenance. There is something called as a laws of maintenance. So how the evolution of maintenance, evolution of software happens when the software evolves. When I say evolution, that means the software is evolving when you get doing the maintenance. So you had it in one release, and it is each time you do a change in the software, you are getting a new release. So what is happening? The there is an evolution in the software. It is changing the state, it is changing its look and feel, it's changing its features. So that is called software evolution. So when the software evolves, there are certain laws of maintenance. So let's look at it, because it's very interesting to know when we write the software what happens after that. As every software engineer likes to do development software, but then after the software is developed, we need to know what will happen to it. So every software product continues to evolve after its development through the maintenance efforts. So that is what I was telling, that a software is not static. So whatever you develop, that is not the end of it. After you have developed, it will go into operation and it will keep on evolving. Its status will go on changing through the maintenance efforts. That is why we say that maintenance, complete maintenance, is the highest cost in the development phase. If you take the process life cycle of a software, the process model, the maintenance phase, maintenance effort will be highest, the cost of the maintenance, because it will live for 10 to 15 years, and throughout those 10 to 15 years you will have to continue to do maintenance effort. But the development is a project. It is a one time effort, and you are going to do it maybe 6 months, or even nowadays 3 months releases are there. So it is a big effort which is done in a very small time, and this is a continuous effort which is doing on a very long time. So the software will continuously change, it will evolve. Larger software products stay in operation for longer time. Why? Because their cost of investment is very high, and anytime if you want to replace it, then the cost of replacement is also high. So it may be easier to replace. Instead of maintaining a smaller software, you may replace it. But if it is a large software, the replacement cost is as good as redeveloping it. It will be higher than the original development cost, because it's happening after some time. So that is why large softwares and good softwares, they will stay in the operation for longer time, and therefore they will go on evolving with the maintenance efforts. The cost of perfective and re-engineering effort is 50%, that means, or higher, of the total cost of maintenance. So now we are talking of the total cost of maintenance. So if you take the cost of the maintenance completely till the software is discarded or replaced, then you will see that the cost of perfective and re-engineering effort is higher. It is 50%. And the corrective maintenance is only 20%. So that is the fixes, the problem residual defect fixes, that is only 20%, or performance tuning, that is only 20%, and 30% could be your adaptive maintenance. So this is the distribution of the cost over this period of 10 to 15 years. Then we come to the laws of maintenance. Good products are maintained while bad products are thrown away. This we talked of it earlier. There will be always a lot of old software which will need maintenance. So because why it will be old? Because it will live for 10, 15 years. By the time it lives for 10, 15 years, it is obvious that it will become old. Because today you might be thinking it is new, you have developed it, but the software will live for 10 years. So by the 10 years, the platform might have changed, the method of architecture might have changed, so many things in the software engineering technology might have changed, techniques might have changed, so the software will become old. So more and more the software becomes older, it needs more maintenance. Then Lehman has given some very good laws, very interesting to read this. Software products must change continuously or become progressively less useful. So if you don't change it and maintain it in the right good state, usable state, then what will happen? It will become slowly, slowly, slowly. That's why he said progressively, slowly, slowly, it will become less and less useful, and it will be thrown away. Then Lehman's second law says when software is maintained, its structure degrades unless active efforts are made to avoid this phenomenon. Because when you are doing this maintenance, you have to do the fix very fast because it is already in release. So it is affecting the business function. So there is a pressure on the maintenance team, the software engineers who are doing the maintenance, to complete the maintenance in very short time. So therefore, what will happen? They cannot give enough importance to maintaining the structure, documents, and lot of things. So somewhere it will degrade, and because it will degrade, unless there is some active effort to make, that means some kind of re-engineering is done once in a while, it will be very difficult to avoid this kind of phenomena of degrading. The third law says over a program's life, its rate of development is approximately constant. So what it means that if it lives for 10 years or 15 years, every year it will undergo a development, and the cost or the effort per year will be almost constant, because initially there will be more of product of bug fix, corrective type, then slowly the adaptive and the perfective ones will take over. So always this rate will remain same, and each time you do a perfective one or you do a re-engineering, then what will happen? Big changes will go, no new releases will go. So again some more errors will come. So bug fixing and perfective will go in cycles. One will reduce, the other will increase. Again, when the moment you do the release, that the bug fixing will corrective maintenance will increase. So the rate or the effort over the years will remain almost same. All large programs will undergo significant changes during operation phases of their life cycle, regardless of the a priori intention. Whatever is the intention that we discussed, what are the causes of the error of the maintenance, irrespective of whatever, regardless of whatever is the intention, it will definitely undergo a lot of changes, significant amount of changes during the operation phase of the life cycle. So when the life cycle, when the software is operational, that time we are doing the maintenance. So maintenance phase and the operational life cycle are the same. Now let's look at why it is difficult to do maintenance, because some people tend to think that development is difficult and maintenance is very easy. But actually, maintenance could be more difficult than development, because development is a forward method. You have got very good structural models and everything and tools to do it. But maintenance is very difficult. What is the difficulty? Maintenance programmers have insufficient knowledge of the system or the application domain, because normally what happens, the maintenance team is a very smaller team, and whereas the development team was a very big team. So the development team, as soon as the project is over, it is discarded, because the project ends, so there is no more funding for them. But what happens to the software? It remains. So there has to be some maintenance people, and these maintenance people may not be the same people who worked on the program, on the development team. And also, even if they worked initially, there will be a lot of change and new programmers will be put there. So that is why the software engineers who do this maintenance, they may have less knowledge on the system and the application domain, also the business domain. Documentation may be absent, or it may be out of date, or it may be insufficient. And even if it is sufficient, it will be so large and so detailed that the maintenance engineer have less time to go over the documentation, because I told you that they are always under pressure, so they have less time. And software maintenance has a bad image, but actually maintenance needs skills, not only in writing code but also so many people think that, oh, we are doing maintenance work, it's not good. But actually it needs more skills than the development. People think that development we are doing, so we are doing great thing, we are learning new types of coding, new types of design. But actually maintenance requires higher skill than development is easy to learn, maintenance is difficult. Why? Because it needs skills of writing code, that is common for development. And this also, it needs proficient in understanding other people's code. So what you have not written, but somebody else has written, and he might have written it 2 years earlier or 5 years earlier, that code you have to understand. So you need to have a extremely good proficiency in the code structures and the code design. And detecting problems, modifying the design, code, and documentation, these are not easy things. Detecting problems, this itself is a very difficult thing. How to identify errors? We discussed about debugging when we came to testing. So there you have seen that debugging or detecting problems is not an easy thing. And also you have to keep up the design, the code and the documentation, and you have to work with end users. So end users, that means you have to deal with customers, and dealing with customers is not very easy because customers are very demanding. So that could be another difficulty in the maintenance. Also, there will be legacy software. What is legacy software? That means something which is written a few years back, and at that particular point of time, currently, if you say legacy, then it is something which is possibly written in the 1900. And at that time, whatever was the way of writing, maybe there are unstructured code and lengthy procedures, inconsistent naming conventions, module structure is not proper, and the cohesion and coupling, that there is a weak cohesion. Means cohesion should be high, but there is weak cohesion, and there is a high coupling. That means there is a lot of interfacing and messages passing through the modules. Deeply nested conditional statements. This increases the complexity of the program, and functions having side effects. So maybe some global data change and too much of calling between, and heavy computationals and things like that. They are not properly decomposed. The decomposition is not proper. It is not decomposed into independent functions. So they will have some side effects. Dependency will be there. So sometimes old systems, they have this kind of problems, and many times they have this kind of problems because the underlying language platform did not support many of these features. So you will get lot of problems. This is another difficulty, but this is slowly disappearing because most of the legacy software is getting changed to object oriented software. So, how to do the maintenance? Now that we have understood what is maintenance, what is the difficulty in the maintenance, what are the types of maintenance, what is the cost involved in the maintenance. So now it will be you must be all eager to know how to do maintenance and how to do good maintenance or better maintenance. So for doing that, you need to learn these concepts: program understanding, reverse engineering, design recovery, re-engineering, and maintenance process models. So we will try to cover a few of this in this lesson, and then we will continue with it in a new lesson, different lesson. So let us look at program understanding. Maintenance involves two types of activities. One is productive activity, the other is non-productive activity. When we say productive activity, that means the maintenance engineer is engaged in doing analysis, design, coding that is required to fix a problem. This problem could be a defect or it could be changes to the system. Some change request has come, some enhancement request has come, or some adaptive enhancements are going on, adaptive maintenance is going on. So he has to do all these activities which are software engineering activities related to that maintenance item. That is what we call as productive activity because he is working on the change. But there are other activities which are also required for maintenance. That is understanding the system design, code, for enhancing his knowledge and understanding. So unless he does this on a regular basis, he will not be able to do this properly. So whenever he doesn't have a productive activity, he is continuously doing this activity, which is not but he is still doing some maintenance activity. That maintenance activity is understanding the system, enhancing his knowledge so that he will do better. For being able to do effective and speedy maintenance, the engineer has to gain knowledge regarding the software's information domain and the design and the implementation. The information domain is the what we do in the analysis models, and the design is your design models, and implementation is the way the code is written, the code structure of the code. The engineer can be trained, and or he can go through the documentation and walk through the software, its design and code. So this is something he has to continuously do. So even if he is trained, the training can last only for few days, but the software is going on changing, so he can't be trained on every aspect of the software, or even if he's trained, he cannot remember everything, he cannot register everything, cannot register to his mind. So I have written and or, so most of the time it is and. Sometimes training is absent, so it can be or, but most of the time it is training plus going through all these items. In the absence of good documentation, a reverse engineering will help. So suppose because of the legacy problem, or because of the age problem, or because of the pressure for doing the fixing the problem in a very small short time, there could be documentation when become poor. So if the documentation is poor, then it is very difficult, you cannot go through and just understand. So sometimes a reverse engineering will have to be done. So that is the next one that was there in our items of concepts, that was software reverse engineering. So what is reverse engineering? It is the process of recovering the design. So we said recovery of the design. So reverse engineering and recovery of the design are one is leading to the other. When you do the software reverse engineering, you are able to recover the design. So if you remember in that slide, we say program understanding, reverse engineering, and design recovery. So that is what we are doing. And how do you do it? Not only that you recover the design, when you say recovery of the design, that means the requirement specification, and the requirement specification also. The requirement specification is determined at the time of requirements analysis, and design is done when you are coming to the design phase, when you are doing the design models. So, and now where you are in the operation. That means the software is already developed and tested, released. So what you will do from the program code that is available to you, this program code is available to you. From here, you are going backwards. You are going backwards, and that is why we say we are doing reverse engineering. We are doing the engineering in the reverse way, in the backward way. And we are trying to recover the design as well as the requirement specification from the code. So the forward is what we were doing so far. Whatever we discussed in the last few lessons was the forward engineering. We started with the communication with the customer, got the requirements, analyzed the requirements, wrote the requirement specification, did the design modeling, and we went to the design specification and did the construction of the code. Now the code is available to us. Documentation has gone bad. The design models have changed, the requirement specification has changed. So what to do? We have to do the reverse process of reverse engineering. So reverse engineering is an important maintenance technique. Several existing software products are unstructured, lack of proper documentation, and it was not developed using software engineering principles. So these are the three causes which will force us to do the reverse engineering. Now, there are some reverse engineering tools. What do they do? They extract the data, architectural and procedural design information from an existing software or a program. So, if you have an existing program or a set of programs which are comprising of the software, then you can give this as an input to the reverse engineering tool. The reverse engineering tool will actually go into these software programs. It will make some different passes into those programs, and it will try to extract the data. When I say extract the data, it will try to extract the data structures and the architectural information. So that means the module interaction and the procedural design of the module. Those things it will try to extract from the software input. And reverse engineering tasks will therefore what that will include? It will include a code restructuring, and it will include a extract abstraction, and it will include a refine and simplify. What is code restructuring? That means whatever code we have, before giving it to the reverse engineering tool or trying to do the reverse engineering ourselves manually, we will have to first do some cleaning of the code. So whatever is the dirty code we have, because we are now forced to do recovery of the design, we are unable to do the maintenance. So now that is why we are going for reverse engineering. So you can 100% be sure that your code will not be in a good status. So that is why we call it dirty code. So the dirty code whose structure has got eroded, or the quality has got eroded, we have to clean it up, bring it to a somewhat better code, so that we will be able to do the reverse engineering. So extracting the abstraction. What is abstraction? Because if you mention, if you are trying to represent something in a higher level without telling the details, that is called abstraction. So all our requirement analysis models were high level abstractions, design level models were a little lower level abstractions, and then specifications, module specifications were a little lower. So what now we are trying to do, we are trying to extract those abstractions which will give us information about the processing, it will give us information about interfaces, and it will give us information about the database or the data structures. So this one we will have to extract from the clean code. And what we will create, what will be the output of the extract abstraction phase? It will be creating an initial specification, initial design or initial specification. Then we will go into the third, last phase of the reverse engineering, that is refine and simplify. So whatever is the initial specification you have got, you might have got it through a tool. So tool will do it very manually. It will not understand so much. It will not have so much of artificial intelligence built into it. So it will only run certain algorithms. And so what is the output of that? Is only called as the initial specification. And you have to refine and simplify it. So you have to keep reviewing it and simplifying it, refining it, until and unless you have created a final specification. So when you determine the final specification, your reverse engineering is complete, because you have recovered the requirement specification as well as the design. And so let's look at the first one, code restructure. We carry out a cosmetic changes to the code to improve readability, the structure, and understandability. We will give more, how we will do it? We will give more meaningful names to the variables, the data structures, and the functions. We will replace complex and nested conditional expressions. And we will only keep three types. We said the structured programming will have to have only sequence, condition, and iteration. Unless you have go to and those kind of things, if you have something other than this, then the tools will not work. And also readability is not there. Now we come to the extract abstraction. So here you are doing only a little bit of cleaning, code restructure, and here you are doing the actual extract abstraction. So this is the core activity of the reverse engineering. It involves developing a meaningful specification of processing, user interface, and the data structures, and that are used in the existing software. So the automatic tools can be used to help derive the data flow and the control flow diagrams. So it will keep on reading the program, maybe 3-4 passes will be done like a compiler, and all the structures will be created, the data flow structures and the control flow diagrams. So something like a flow chart, or and also a DFD, and other information from the code. You can also create the structure chart, which is the module invocation sequence, the way the modules are structured within the architecture. So structure chart is a part of the architecture. So we are deriving the architecture model, and we are deriving the DFD model and the control flow diagram. Control flow diagram is a specification, program module specification. This is the analysis model, and this is the design architecture model. So this is what we are trying to do. If you have a completely automatic tool, otherwise you will have to have a semi-sir. So what it will do, what the tool will do, first it will understand the data. Objective is to move from conventional data design to object-oriented design. So that is our objective in the reverse engineering. So when we do the reverse engineering, so we said data structures, user interface, and processing. All the three things we have to do the specification. So it will understand the data first. It will go through the internal data structures, all the program level internal variables structures, to convert the abstract data types such as record structures, files, lists. So it will do this conversion, and it will provide an initial indicator of the classes. So because finally, when you want to do the forward engineering after the reverse engineering, you will need to do it into object-oriented methods. So from the existing data structure, we will try to get the indication about the classes. Similarly, the database structures objective of re-engineering is to move to relational or object-oriented database. So whatever are the files or whatever way the data is kept, maybe in an older type of database which is not a relational model, or nowadays everybody uses object oriented model, so you want to change to the better database, so you will build an initial object model, then you will determine candidate keys, refine the tentative classes, define the general, because normally what will happen, the classes will have its own relation. So the inheritance will come, so you will know how the data will be structured in the database, and you will define all the generalizations and associations. So that is what I was telling, the class, from the class and the data structure, the class generalization association and its underlying data relations, kind of entity relation diagrams. So both the database as well as internal data structures will have to be understood by the extract abstraction step. And then you have to do the understand of the processing. So you will create from the code that you will analyze, you will have to do different levels of abstraction: system level, program level, component level, patterns and statements within the component. So you can create some block diagram, either you will do it manually or the tool will do it, to represent interaction between programs, and you can get a functional abstraction from it. You can do procedural abstraction, that means within the function, within the program module, how the algorithm runs, and these are obtained from the program and its sub functions, how the program sub functions, how they are actually writing the procedure of the function, how they have realized it. Then you will see some patterns. Patterns means, that means you will find some commonality among the different program components. So some certain sections will be doing data validation, some certain sections will be doing error processing, computation. So in object oriented, what we try to do, we try to make it separate, or data validation is one type. So we create common kind of modules for these kind of common functions. So you can start doing these patterns and decompose it accordingly. So several reverse engineering tools are available. Some will provide semi-automatic support. That means they will one by one they will give you some diagrams or some information in some structured form. And also some fully automatic tools concept is there. They can be used to understand the semantics of the source code, so they're slightly intelligent than the normal tools, and the output it can be directly fed to a forward engineering tool to complete the re-engineering. So after the reverse engineering, you have to do the re-engineering, the forward pass, to create the better, but the purpose of the reverse engineering is to be able to extract the specification, so that you will create a better system, better software, which will be replacing the older software. So there will be some re-engineering, the forward engineering. So if it is fully automatic, the concept is that you feed your whatever is the existing system to the automatic tool. It will do the understanding, it will create whatever intermediate structures it is going to create, and those structures will directly get to the next phase of the automatic tool, and the final models will come out. So once the final model comes out, then you can use your computer aided software engineering tools to engineer it, to actually implement it. Then you have the user interface as part of the re-engineering. Some of the interfaces, GUI, the graphical user interface or web-based interface will be required. So reverse engineering has to be done on the existing system, because improved GUI has to be created. So what you have to do, you have to go to the what are the user actions that is being done, how many different action kind of buttons are there, or kind of commands are there, because it might be text based or character based, and not GUI based or web based. So, and what is the behavioral response to the system when the action is being taken by the user? How does the system respond to it? What is its behavior change? what is the equivalent interface component that can substitute these in the action and response. So suppose you want to move it from the existing system to a new system which will have better interface. What is that interface concept, either in GUI or in any other mobile or in your web app, how it will be. So what is that concept, new equivalent interface concept that will substitute the old one, the old one of action and response. And then you can do some behavioral modeling. Some techniques can be used to with the existing UIs, and then the corresponding processing program module. So you can connect the UIs, existing UIs, with the corresponding processing program module, and you can create some behavioral modeling techniques. We have seen behavioral modeling technique when we have discussed the analysis model. So you can do something similar to behavioral modeling. So we have come to the end of the extract abstraction. That was the core activity in the reverse engineering. So I hope you have understood what is reverse engineering, how the code is fed to the reverse engineering process, and by different iterations, it tries to get the data specification, the user interface specification, the processing interface, the architecture, the design, and everything. So whatever you need now for the forward engineering. So we come to the end of our lesson today. If you'd summarize what we have seen today, we discussed some fundamental concepts in software maintenance initially, and then we said that there are four major types of maintenance activities, out of which perfective maintenance, or which includes the re-engineering, is around 50% of the total maintenance cost. So this re-engineering, we will see what is re-engineering. Actually, reverse engineering is one part of the re-engineering. As maintenance is the most expensive phase of the software lifecycle, during the development, you will have to think about maintainability. If you don't think about maintainability, if your product is not maintainable, then your maintenance cost will be very high. So to reduce the maintenance cost, when you do the development, you have to think of them, just as you have to think of the testability. We discussed that during testing, that development team has to think of testability. Similarly, the development team has to think of the maintainability. That is why these two are two very important product characteristics or product metrics in our for our development phase. So then you have to carry out the good maintenance. We need to know these concepts, that is program understanding, reverse engineering, design recovery, and these two are complement to each other. Then software engineering, which we will cover in the next class, and maintenance process models. So in this class, what we did, we looked into what is program understanding, and we said that program understanding, we need some tools that will do the reverse engineering. So we have to see what are the steps in the reverse engineering. So we saw that there are 2-3 steps in the reverse engineering, and at the end of it, it is able to extract the design from the code. And we also discussed that reverse engineering is best achieved by some tools that are called analyzer tools. Just as forward engineering is aided by the computer aided software engineering tools, so also for the reverse engineering, we need this kind of analyzer tools which can analyze the code and give us design information. So we have come to the end of this lesson. Thank you all for giving me a very patient hearing. Next class, we will continue with this activity of maintenance, and we will look into the re-engineering aspects. So thank you all.